A burning bar is a steel tube filled with alloyed wire. The process is actually a chemical reaction. When steel is heated to its kindling temperature, it will burn if pure oxygen at the proper pressure and volume is injected into the heated steel. The reaction is referred to as an exothermic reaction. The exothermic reaction is continued as long as the proper volumes of both fuel, molten steel, and oxygen are maintained. The thickness of the material that can be cut and the speed of the cut will be determined by the pressure and volume of oxygen that can be injected into the cut. It cannot be emphasized enough that the volume and pressure of the oxygen is critical to efficient cutting. To ignite the burning bar, the operator first opens the oxygen control valve to check for leaks and proper flow. The control valve is closed, and an assistant heats the tip of the burning bar with an oxyacetylene torch. When the end of the burning bar is red hot and slightly molten, the operator opens the control valve to ignite the burning bar. As soon as the bar is ignited, the cutting process can begin. Cutting with burning bars is actually easier than with a regular cutting torch. Burning bars work best when the tip of the pipe is in contact with the material being cut. You do not have to maintain a tip clearance. Laminated steel or bundles of steel, such as heat exchangers, can be cut with ease. The operator in this case is cutting a tube bundle that is 18 inches in diameter. The complete cut was accomplished in 3 minutes and required less than one 10-foot 6-inch burning bar. Steel that is embedded in concrete or lying on the ground can be cut without cleaning or preheating or without blocking it up. The material being cut is 5/8-inch thick steel embedded in concrete. The length of the cut was 5 feet and was made in 2 minutes. This was a test for a decommissioning project at a nuclear power plant. Oxylance maintains a fleet of vaporizer systems for rent or sale. These systems are complete with manifolds and regulators. They can provide up to 5,000 cubic feet of gaseous oxygen per hour, 83 cubic feet per minute, from 4 standard liquid oxygen cylinders. This contractor is performing a demolition project that involves a large injection mold machine. The material the operator is cutting is 26-inch thick steel. To efficiently cut this material required a 1.05-inch burning bar. The oxygen flow rate to make this cut was 80 to 90 cubic feet per minute at 150 psi. The cutting rate for the 26-inch thick material was 1.5 inches per minute. The operator is wearing the latest protective clothing from Torchwear, the triple layer Carbon X. Materials that will oxidize, rust, cut rapidly with Oxylance burning bars. Materials such as copper, brass, and bronze will cut at a much slower rate because these materials will act as a heat sink. Cutting non-ferrous materials can be accomplished by melting material and then blowing the slag from the cut. Materials such as aluminum and titanium cut rapidly and produce very high heat. The operator in this case is cutting up aluminum waste at an aluminum foundry. The material ranged from 10 to 16 inches thick and contained a lot of refractory and slag. The cut rate on this material was 3 inches per minute. Cutting with burning bars can be accomplished by either dragging the burning bar across the material or pushing it into the cut. The primary concern is to move the slag out of the cut as fast as possible and keep as much heat in the material as possible by keeping the burning bar in constant contact with the material being cut. Frozen pins can be removed from paper mill rolls or heavy equipment by piercing a hole through the center of the pin. In this case, the pin is 5 inches in diameter and 16 inches long. The time required for the initial pierce through the center of the pin was less than 1 minute. Enlarging the diameter of the hole 3 inches required an additional 3 minutes. By enlarging the hole, you give the pin more room to shrink when it cools. Cooling the pin took 5 to 7 minutes, and the pin was removed by hand. Prior to starting the operation, the operator welded a pull bar on the end of the pin. The bar serves 2 purposes. The burning bar can rest on it to aid the operator in keeping the burning bar centered in the pin, and when the cut is complete, the operator can use it to pull the pin out. The total time was less than 10 minutes and required 1 burning bar, size .675 inches outside diameter by 10 feet 6 inches long. The diameter and length of the pin will determine what size and length burning bars should be used. Our technical service department can recommend the best equipment for a particular application. Call 205-322-9906, extension 2.